Hello, everyone. My name is Ivan Bessonov. I'm a lead software engineer at GridGain company, for the most part responsible for storage implementations. Today, I want to present you a small presentation about core architecture in Ignite, mainly related to data distribution in your cluster. So our plan is to talk what we have in Ignite 2, to talk what we have in Ignite 3, and compare it to show the main differences. Let's start with the cluster topologies. That's the most fundamental aspect of Ignite 2. It has multiple Ignite nodes. Together, they form a cluster. We have such terminology as cluster topology. It is a collection of nodes that are currently alive. They're not shut down. They're not in the process of joining. They're just your regular Ignite nodes. And we have a different name called baseline topology. It has a completely different meaning. Baseline topology is a logical collection of Ignite nodes, and all of those nodes might be used to store your data. The main difference between cluster topology and baseline topology is that some of the baseline nodes might be temporarily offline, and some of the cluster nodes might not be included into baseline topology. So in general, they just intersect. The baseline topology is obviously a one thing, a one collection of nodes. It might be managed automatically by the system using the auto adjust setting in milliseconds. What it means is that after the cluster topology change, the system will wait a defined number of milliseconds and only then include or exclude a node from or to baseline. Or you can change the baseline manually. There are two ways to do that. Set the explicit list of node IDs or to use some known topology versions. What do we have in Ignite 3? First of all, in Ignite 3, we completely updated the approach to discovery service. And with that approach, we have now a flexible way of showing you what is happening in your cluster. First of all, there's so-called physical topology. It is all alive Ignite nodes that you have, and nodes that are currently starting and maybe not yet join. Maybe they're doing the recovery or some other maintenance tasks. And another concept is logical topology. It is the thing that is equivalent to cluster topology in Ignite 2. It only contains alive nodes that are already joined to the cluster and that, in theory, can store your data. You see that there is no concept of baseline topology. There is a thing similar to baseline, but we don't call it topology anymore to avoid confusion. I will talk about it a little bit later. That's enough about topologies. Let's talk about the things that work within those topologies. In Ignite 2, we have a concept of cache groups, underrated in my opinion. So most people use just caches, not cache groups. So cache group is a collection of caches that always have the same properties related to distribution of data. So they have the same affinity function. It is the distribution of partitions and backups and maybe backup filters and other fine-tuned settings. And caches are always stored data within the same data region if they share the same cache group. And of course, the data is rebalanced together. Everything is stored together. Data is always collocated. The issue, or let's say some implementation details about cache groups, is that, well, obviously, each cache group is a subset of baseline nodes, but the baseline, it has its own management that is shared between all the cache groups. If auto adjustment of baseline happened, it affects all cache groups, obviously. There's another issue, let's say, or maybe some detail about the implementation of cache groups is that fine-grained configuration of cache groups is pretty hard to achieve using, I don't think, clients, for example. You sometimes must use Java predicates, Java class names in your configuration, and that means that some of the things can only be configured in static XML configuration or in thick clients through Java code or in embedded servers through Java code as well. What do we have in Ignite 3 to replace cache groups? First of all, it's not caches anymore, it's tables. So we have to get used to a new terminology because, the caches, it's like a little old school. Distribution zone is just a collection of tables, just as cache group was a collection of cache groups. These tables are always stored together at the same set of nodes. Distribution zone dictates your settings, such as partition, backups, and so on. But also, distribution zone is similar to baseline topology because it has the settings that auto-adjust the nodes that are included in distribution zone. Let's take a closer look at settings that we have. First of all, there's an example. These are obvious things that you can configure: the number of partitions, the number of replicas. Replicas might look like a new term. It's just a number of copies of data that we store in Ignite. Previously, we used the term backups, so replicas is basically backups plus one. This is the syntax that we use in SQL. There's a keyword with, and then you have comma-separated list of keys and values. What else can we add to that comma-separated list? Settings that in Ignite 2 corresponded to baseline. Now you can adjust your distribution zone automatically using 2 timeouts instead of 1. So the scale up timeout is a number of milliseconds that the system will wait between joining new nodes and adding it into a distribution zone. And the scale down timeout is a time period between Ignite detecting that node left logical topology and its actual exclusion from the distribution zone. Let me repeat this. These values are now in seconds, not milliseconds. It makes much more sense. Other parameter includes the node filter. It is a string in JSON path syntax format that dictates the nodes from logical topology that will be included into a distribution zone using the filter configured on top of node attributes. So what is a node attribute? It is a key value map, basically, where key is a string and a value is a string. And user can configure anything that they want. For example, here we have a syntax for local node configuration in which we add attribute region with value US and attribute storage with value SSD. Every Ignite node might have a different set of attributes, and thus you can use arbitrarily complex filters in your distribution zones if you want to. Let's get back a little bit to Ignite 2 to look at the notion of data region. Each cache is located in data region. It is basically a chunk of memory that is used to store data. And in Ignite 2, there are just 2 types of data region that are configured by a single Boolean flag. If you enable persistence, your data will be stored in memory and on storage device. In other words, it will survive node restart. Or if persistence is disabled, the data is only stored in memory. And if you reboot your entire cluster, the data is lost. You have to upload it once again. That is the classic cache scenario. In Ignite 3, first of all, we once again renamed things. Now it's called profile or storage profile. We don't call it data regions anymore. And for distribution zones, you might configure several storage profiles, not just one. And the idea is that all the nodes within the distribution zones have all these profiles configured in them. And if we have a node without some storage profile locally, it will not be included in distribution zone. Important property of that is that now you don't have to have all data regions on all Ignite nodes. So you might have some nodes without certain profiles. This will save you some configuration. Maybe it will save you some resources. This is how you configure the storage profiles. Again, it is done locally on your Ignite node. Here we have an example of profile named default with size of this amount of bytes and so-called engine equal to AI persist, which is equivalent to having data region with flag persistence enabled equal true. As you see, now it's not just a flag, it's actual value of the engine. And the idea is that for Ignite 3, in principle, we are free to add as many storage engines as we like, and thus as many types of storage profiles as we like. And of course, I must say that you can reuse the same storage profile between different distribution zones. That's the idea. It is fine to only have a single storage profile on every Ignite node throughout the entire cluster, even if you have 10 distribution zones. That's not a problem. Now, how do you assign all of that to the actual table within the zone? Here we see an example of syntax of how you can create a table. And these are specific keywords in our syntax called zone and storage profile, where you just mention them. What happens when you don't mention it? If you don't mention the zone, the default zone will be used. If you don't mention the storage profile, it will use the default storage profile within the zone. So you don't have to mention anything, it will just work. And of course, the default zone, it always exists in your cluster, so you don't even have to create it manually. Once again, let's talk about architecture of Ignite 2 and one of the infamous parts of the Ignite 2 architecture called Partition Map Exchange. There we have a legacy stop the world mechanism that stops all the transactions, does something, and starts transactions once again. So it creates a pause. This pause is used when we create or destroy cache, or for example, join a new server nodes, or we remove a server node from the topology. And of course, given that it is a stop the world mechanism, it creates spikes in your transactional load, which is not desired. And on top of that, it used to be abused in several places of the code. As far as I know, we already fixed most of it. But sometimes you would see occasional spikes where you would not expect them. For example, obviously, when you have a cache A and you create cache B, you don't expect that cache A will suffer from just creating of independent structure. In Ignite 3, given that Ignite 3 is a new project with mostly new code, we abandoned this old legacy mechanism and completely changed the approach to managing data distribution. And here are just a few properties of the new approach: that distribution zones, they do not affect each other. When you join node or when you remove node from the topology, it does not affect your transactional load, with a few exceptions. For example, if you remove the node that had a volatile lock table for your transaction, well, obviously the lock table is lost and the transaction will have to be rolled back. That's inevitable. But otherwise, when you create new zone, when you create new table, it does not affect the transactional load of already existing zones and tables. Even table destruction does not affect transactions that had nothing to do with this table. And in general, all the DDL operations and updates of cluster state are much less invasive. They do not affect your transactions as critically as it was in Ignite 2. Speaking about transactions, in Ignite 2, we had two types of caches, judging by their transactional types or isolation levels. We had atomic transactions. We have transactional transactions. Yeah. We decided to just abandon this dichotomy. We decided that, well, let's not use it anymore. Let's be as strict as possible. Let's create transactions that will satisfy everyone. And we chose the strict serializable isolation level. It is used by default everywhere, and obviously there's no way to change that. Don't be afraid. It's not too much slower, and simple operations like single put, they are effectively atomic puts, and there's really no speed difference between atomic puts and puts within strictly serializable transactions in our case. What's also good is that all these serializable transactions are also supported in SQL. Like there is no difference between kvalue API and SQL API. They work equally good with the same guarantees, and you can even use both kvalue API and SQL API within a single transaction. Should just work. There's also some small adjustments to the types of transactions themselves, not transactional modes that we have. So if you want to write data, of course, your transactions must be isolated. You have to, the system has to acquire some locks, and this is sometimes might be less efficient, especially if you have big transactions. And when you acquire locks, of course, you have potential deadlock situations in which transactions must be rolled back, or the node that has lock table might leave the topology and transaction must be rolled back, or etc. So these are like heavier, more serious transactions. And then we have transactions that only read the data. These are faster. These might be executed in a lock-free mode, because if you only read data, there's no way you are in conflict with anyone. And of course, if you don't acquire locks, there is no way to get into a deadlock situation. There is much lower chance of read-only transactions being canceled by Ignite itself. Another interesting point is that read-only transaction will be continued even if you drop the table you are reading from. Because in Ignite 3, we now have multi-versioned storages, and each read-only transaction basically has its own snapshot of data. And that snapshot of data will only be invalidated once it is not used anymore. And while you are reading, obviously until some timeout, you are free to finish your read-only query, and only then the data will be actually deleted. In GridGain 9, there's another mode for reading data. Ignite 3 is OLTP-oriented system, but some queries are like analytical queries, and they don't really work too well on LTP systems. So GridGain 9 gives you the capability of using optimized storage engines for analytical queries specifically. If you configure that, and I invite you to visit the talk by Yury Yudin, my colleague, about this exact topic. Now that's about it. Let's reiterate what we have discussed today. The cluster topology in Ignite 2 is now split into the physical topology and logical topology. It allows you for a better monitoring of the cluster and generally makes more sense. The baseline topology with its auto adjustment now becomes distribution zones with independent auto adjustment settings. Cache groups with affinity function, an arbitrary affinity function, now became distribution zone with rendezvous affinity function with partitions and replicas that you can set from any API. Node filters in cache groups that used to be arbitrary Java predicates now became a structured valid configuration of distribution zones. You can do that through the SQL API. Cache groups with a single data region became distribution zone with multiple storage profiles, meaning that in a single distribution zone, you can have one table with one engine and another table with another engine, and they will still share the same distribution. There is no more atomic transactional atomicity mode. There's only strict serializable, and there's now the distinction between read-write and read-only transactions. And the best part, of course, no more partition map exchange. The transactional load is much more smooth, and it is not affected by your events like not join and not left. So yeah, that's about it. Thank you very much.